All right, welcome to part 2 of topic 6.13 video here. So last time we looked at improper integrals that had infinite bounds. Now we'll look at improper integrals that have infinite discontinuities. So if f is continuous on the interval and has an infinite discontinuity at b, so the upper bound, then we take the limit as x or c approaches b from the left of this integral. If it has an infinite discontinuity on the lower bound, we approach a from the right. And if it has an infinite discontinuity at some point inside, then we can split it up into two integrals like this and do two separate limits. All right, and again, the improper integral will converge if the limits exist. If the limits don't exist, we say that the improper integral will diverge. So let's take a look at number 6. We can see right away that this, this has a discontinuity at 0. So we're going to have to take the limit as some number a approaches 0 from the right, from a to 1. I'm just going to rewrite this as x to the negative 1/3 dx. All right, now let's do that. So limit as a approaches 0 from the right. It's going to be x to the 2/3 over 2/3, so that'd be 3/2 x to the 2/3 from a to 1, which is limit as a approaches 0 from the right of 3/2 minus 3/2 a to the 2/3. All right, now if I put 0 in for a, I get 3/2 minus 0. So this answer will get closer and closer to 3/2. The closer and closer the bottom bound gets to 0. Again, we have number 7 here that has a lower bound issue. The lower bound is not continuous. The function is not continuous at the lower bound. So I'm going to write what I wrote in the last one, limit as a approaches 0 from the right of our integral from a to 2 of, I'm actually going to change that to x to the negative 3. So that's limit as a approaches 0 from the right of x to the negative 2 over negative 2. So that would be negative 1/2 x squared. So negative 1 over 2x squared from a to 2. So that's limit as a approaches 0 from the right of negative 1 over 8 minus negative, so plus 1 over 2a squared. So we have negative 1 over 8 plus, as this gets closer and closer to 0, this will get closer and closer to infinity. So we say that this integral diverges. It does not get closer and closer to some number. It gets closer and closer to infinity. All right, what if it has an interior discontinuity, like number 8 does here? So this is going to be not continuous at 0 again. So what we're going to do is we're going to think of it like this. We're going to break it up into the integral from negative 1 to 0 plus the integral from 0 to 2. And now we're going to do double limits, right? So limit as b approaches 0 from the left plus limit as b approaches, as a approaches 0 from the right. All right, now I can take my antiderivatives. X to the negative 2 over negative 2, so negative 1 over 2x squared again, from negative 1 to b. Okay, and let me just give me a second to make this a little smaller here as I'm running out of room. All right, so now if I substitute in my bounds, I would get negative 1 over 2b squared minus, so plus 1 over 2 times 1 plus limit as a approaches 0 from the right of negative 1 over 8 minus negative, so plus 1 over 2a squared. If I substitute in 0, if I approach 0 here, that denominator is going to get smaller and smaller and smaller, which means our answer is going to get bigger and bigger and bigger. So it's going to be negative infinity plus 1/2 minus 1/8. And again, this is also going to be 0, so this will also go to infinity. So again, we would say this integral diverges. Okay. That's actually going to be it from here. I'm not going to go through number 9. Just going to get rid of that one for here. But one last thing that I want to point out to you before we get out of here today. This is a theorem about a special improper integral that could be used on some multiple choice questions to save a lot of time. If you don't memorize this theorem, you can still do the problem, but it's something that can really help a lot. If the integral was from 1 to infinity of 1 over x to the p dx, the answer is going to be 1 over p minus 1 if p is bigger than 1. Always. If p is less than or equal to 1, it's going to diverge. Okay? That will do it for our lesson today on improper integrals. Thank you, as always, for tuning in to the video today.